Hope everyone is having a good day today. Second last session of the day, almost there to the drinks and the after party, so yeah, getting close. So my name is Shaquille. I actually am head of the networking specialist essays for Asia Pacific and Japan. And today we're going to talk about how to build resilient and secure networks globally within AWS. So here's I put a picture about a modern network, what it looks like. Back in the days, networking was simple. I mean, the traffic patterns were visible. Like we used to know that a lot of employees would be in the offices, they will be in the branches, and the applications were in the data center. So the traffic profile of the applications was quite steady. We knew the traffic patterns, we knew where to provision what and how to do over provisioning and where, etc. But post-COVID and even with the cloud appearing, modern networks look something like this. We have, you might be using 2 regions. You might have your SD-WAN connections coming in from branches. You might be using client VPN technology to get your users into the AWS environment. Or you might have on-premises firewall today, and you might have some workloads on-premises as well. Then we talk to the customers, for example, when they want to reach out to another different region. For example, let's say they want to expand into Indonesia. So with the cloud, it's really easy. Back in the days, it was really hard that you have to work with a vendor to buy MPLS connectivity, take somewhere like 6 months. But with the cloud, now the advantage is that you can actually get that connectivity readily available using SD-WAN technologies, using VPN, or you can just use our backbone to pair all these connectivity between the cloud, etc. So resiliency means different things to different people, right? I'll let you read the definition we have in the well-architected framework, but pretty much it's the capability to be resilient, to recover when your workloads are stressed. It might be an attack, it might be like a bug, it might be service impairment, for example, right? But this is our official definition from our well-architected framework. And then we look at the resilience pattern. I think if some of you have joined earlier chat from Radha today, she covered some of these patterns. Like as an architect, we take a step back. Resilience, and when you build resilience in your applications, in your networking, for example, it's a choice. You can build very, very highly resilient network, but it comes at a cost. It might be operationally not efficient. It might be very complex, right? So this actually kind of gives you an idea, like what are those patterns? What are those trade-offs? I've put a QR code. You can actually read more about like how actually resilient patterns works and what are those trade-offs. But I wanted to put it here that some of those networking patterns are also driven by these architectural decisions you are going to make. You might have an application requires, distributed application portfolio, and you might actually choose to, deploy P3, for example. Or if your applications are non-prod or like test environment, you might actually go with P1 because that suits your environment, right? So even though we're talking about network, but we need to keep in mind that network we are building is for applications and for workloads, right? So we need to fall back to these patterns of the application availability, etc. So let's go on a journey. The way I've structured slide today is like we'll start from inside the VPC, how we have resiliency within the VPC. Then we'll jump out of the VPCs, between the regions, and then we'll go global, and we'll talk a little bit about Cloud WAN at the end. So let's start within the VPC. So if we look at just a basic VPC, nothing else. We have a single availability zone. Within the availability zone, we have a NAT gateway. You might have some public workloads like load balancers, and you might have some private workloads as well in the VPC. At bare minimum, you might be using Internet Gateway. So Internet Gateway itself, very highly available. It's a regional service. You don't have to worry about the resiliency for Internet Gateway because we manage that resiliency for you, right? But when it comes to NAT Gateway, for example, or the workloads you are putting in a single availability zones, these are all zonal services. So in case there is an impairment within that availability zone, or like, for example, if your EC2 instance for your workload is affected by updates, by rolling up, whatever changes it can be, right? That means your applications and workloads are affected, right? So how do we get out of this space, right? And the natural thing is that we will add more availability zones, right? To add resiliency into our network or into our applications, we add more availability zones, right? Now, this is an architecture which introduced multi-AZs, but if you notice that you might be using auto-scaling groups, right? You might be actually using on-demand capacity building. Let's say if your AZ of A is impaired, you start building those resources in the other availability zones as you're trying to fix the problem. Now, the downside is that there will be disruption. There's, for example, if the AZA goes down, users might not be able to access the workloads until you have provisioned the resources into the secondary availability zone or tertiary availability zones as well. So this is a bare minimum that you can do. You can actually add availability zones on demand when there's an impairment. You just start spinning up resources in the other AZs. And back to the point that depending on your application profile, it might be acceptable to your business, but it may not be acceptable to your business, right? And if it is not acceptable to your business, we always fall back on something called static stability. Like Radha, actually, in very detail, she talked about what static stability means. Basically, statically stable systems, they remain stable. If we take out capacity from, let's say, availability zone A, it shouldn't impact the users because we still have the other availability zones. So when we are building multi-AZ architectures within the VPC with static scalability, what it actually means is that you are actually building all your key and critical components within the VPC. What that means, you are actually building your elastic load balancers, making sure that they are actually spanning across multi-availability zones. You have zonal NAT gateways, right? You don't want to be in a position where you have a NAT gateway in only one AZ, and then all other AZs are dependent on that AZ. I mean, you can do it, but then if that availability zone is impaired, then your other AZs are also impacted by that event in a separate AZ, right? So static, stable systems require you to have, build these silos that your systems are stable if one AZ goes down or if, one cell goes out of the picture, right? So in this case, you can deploy your workloads across all availability zones and across the regions as well. Now, often I talk to the customers and they talk about, there's gray failures and then there is hard failures. Hard failures are really easy. Like if a system goes down or if a link goes down, for example, in networking, we know what to fix. We will back up, we'll use backup and stuff like that. But then something we don't often talk about is gray failures. What are those gray failures? Like software bugs. For example, bad config, it might be reduced capacity. It might be a packet loss or latency, right? And then you get into situations where you need to answer those questions. What happened when this will be down? Or what happened when the performance it's up, but performance is slow, right? So those are the kind of questions which we get on the gray failures. So back last year, we introduced something called Amazon Route 53 Application Recovery Controller, a long name. But what ARC or Application Recovery Controller allows you to do is it allows you to safely, reliably, manage how you want to do cross-AZ and cross-region recovery. How we do it, there's three options. It allows you to do zonal shift. Like you can actually make an API call, a single API call that I want to get out of this availability zone, and the ARC will make sure that your load balancers fail over and you're only using other availability zones for the time period you define, right? Then there is routing controls. Then there is readiness checks. So readiness checks allows you to actually go in and check your configuration of the applications that all those checks are passed, and define those if conditions of the gray failures. That if this is ready and if the latency is this and that, and then otherwise use zonal shift or trigger whatever you want to trigger, right? So if you look at how does it work with static stability and how ARC comes into the picture, so imagine this customer who's running elastic load balancer in 3 availability zones with static stable, all the NAT gateways, all the workloads are replicated within each availability zones. And then something in the monitoring system, they note that the latency for AZA and AZB is actually probably normal, 60 milliseconds, but in the AZC, we actually have 1 second latency, right? So based on this metric, depending on how you've configured it, how you're monitoring it, you can actually make an AZ call that I want to shift away from these availability zones using ARC, and you can define a period, and then the whole AZ within seconds will be out of the picture, right? As soon as the DNS entry is refreshed, and depending on your customer's DNS cache options and the timers, only 2 of AZs will be present in the answer of the load balancers, and then customers will be using those only 2 AZs. And as soon as it recovers, your readiness checks are back, you can actually go back and make sure that AZ is available to your customers as well. So make sure you look at ARC or Application Recovery Controller and how you can incorporate into your networking profile using load balancers, et cetera, there as well. So how do we scale from? So this is single VPC, right? So we need to scale out. We know that single VPC doesn't work. We know applications will require multiple VPCs. They require multiple accounts, sometimes even multiple organizations, you have to go and VPC pair with partners or private link, etc. So how do we scale from here? So talking about resilient connectivity between VPCs, I'm sure most of you would be familiar with VPC pairing. So VPC pairing is an old construct. It's quite highly available. It's resilient. It uses our backbone within the data centers or within our regions, within our availability zones. You can have these two VPCs in different regions, and still it would use AWS backbone. We encrypt the backbone. We make sure that all the packets are secure, highly available. Let's say if these two regions are Melbourne and the US, or Sydney or US, for example, we have multiple fiber systems or 100 gigabit Ethernet backbone, which we fully utilize, and we make sure that there is resilient connectivity between the VPCs all over the place, right? There are some pros and cons of the VPC pairing. I won't go through the list, but I think focusing on the cons, VPC pairing is a one-to-one relationship. It doesn't scale. And we've heard this from customers many, many times that it doesn't work, it doesn't scale. And then back in 2018, we actually launched something called Transit Gateway. And Transit Gateway resolved the problems we had, the scaling problems we had with VPC pairing and issues we had with Transit VPC back in the days. And Transit Gateway fixes all those problems. We know it's highly available. It's a regional service. So it's highly available by nature that if you're using it in a region, we actually provide you SLA on top of it. It's resilient by design. It can give you 50 gigabits per second throughput per AZ as well. And it's two-way communication, etc. Now, the downside is it has data processing cost onto it because we process the packets using Transit Gateway. And VPC pairing, if you're doing within the region, sometime within the AZ, there is no cost, etc. So it's a trade-off. Again, back to that thing that when you're making a network, you need to trade off complexity versus ease, but then cost is a factor. So when I talk to customers, a lot of them ask around, how highly available is Transit Gateway? So and generally, the answer is that Transit Gateway is a regional service. It's by design highly available. The control plane and data plane are separate, and how we build. We've often talked about hyperplane-based cellular architecture. So if you scan the QR code, you'll probably get more details around. We've talked about at reInvent how hyperplane works and how cellular architecture it is. The second most asked questions I have from customers is that how many Transit Gateways do I need? And then my answer is that most of you probably just need one because it's highly available, right? You don't need multiple of them, right? But depending on the change control and requirements, some customer may choose to go more than one. You might have a requirement that I need to physically separate my prod versus non-prod. And we do have customers who actually do requirement that 100% separation between prod and non-prod. And at that time, you might actually just create a non-prod transit gateway, non-prod direct connect links, non-prod VPCs, et cetera, all the way to your on-premises, right? So there are certain requirements from your point of view. Absolutely go for it. Build another transit gateway. But the nature of the service is highly available. It is resilient. So most of you probably can just use one transit gateway. If you need to have separation within the transit gateway, you can use transit gateway route tables to separate prod, non-prod, but then you're still using single transit gateway itself. All right, so then talk about security. So we launched Gateway Load Balancer a couple of years ago. Gateway Load Balancer allows you to actually insert middle boxes or firewalls like Palo Alto, Fortinet, even our own offering, AWS Network Firewall, into the picture. You can design the VPCs in a central manner where you have central inspection VPCs, which can potentially do, let's east-west, for example, right? Between your workloads, between prod, non-prod, and shared. So absolutely look at the patterns. We've often talked about it. And at the end, I've actually put in some QR codes as well, where you can look at how to insert firewalls at scale in your VPC design and make them resilient. There are patterns available for north-south as well, where you can actually have the same firewall do egress filtering towards the internet, centralized as well. And there are patterns like distributed design, where you can put firewall in each and every VPC, but then it costs a lot, right? So you want to make a decision like, what is more important, operational complexity versus cost, right? So, and the blogs I linked at the end will probably give you a better answer around which to choose when. And depending on your business profile, you might actually fall between one or the other. So what is the network firewall offering? So if you look at network firewall offering, basically the shared responsibility matrix is that customer manages the firewall policy. Customer, you would make sure that the traffic is being routed to the firewall using route tables in the VPC, using route tables in the transit gateway, and then you can control it using firewall manager. What AWS does on our side is that we actually automatically scale about the traffic. The firewall will automatically scale whatever traffic you throw at it. We support up to greater than 45 gigabits per second traffic, and generally we tell customers that if you need more throughput on the firewall, talk to us. We can make it work for you. It gives you resilience SLA around 99.99%, and then it's zonal affinity and all session symmetry is also maintained for you, right? And how do you build resilient VPC design? So fall back to the initial thing we have, that we need to use multi-AZ design, especially with firewall insertion. When you insert your middle boxes or your Palo Altos using gateway load balancer, you want to make sure that the endpoints you're configuring are available in all AZs wherever your workloads are. So if we look at the inspection VPC design here, we have a transit gateway attachment subnet where transit gateway comes in. And then we make sure that the firewall endpoints are configured for each and every availability zone, right? So make sure that you understand the firewall is a zonal concept. Just like NAT gateway, you want to make sure the endpoints are each and every availability zone to make sure your inspection VPC is highly available. Cool. I'll pick up pace. I've only got 30 minutes. So let's talk about hybrid networks now. How do we do resiliency? So very high level, this is how hybrid network looks like. You might have a direct connect gateway, which is connected to a direct connect location, and you might have a router on your side, which is connecting to our gateway in a location, right? And then we take that traffic from direct connect locations back into the region, right? And if you attach it to transit gateway, you can inspect the traffic and the whole lot, right? So if you notice here that these are single devices, right? You might have to do performance maintenance on your side. And if you've used Direct Connect or VPN, you might be aware already that we also have to perform maintenance on our side, right? There may be a case that AWS gateway might be down for maintenance for like an hour or so, which means your production traffic would be impacted or non-prod traffic would be impacted. So how do we fix that? Number one option you have is site-to-site VPN, right? A lot of customers, when they start their cloud journey, they fall back to VPNs. VPN does allow you a backup connection, but then keep in mind that we don't generally suggest that use the VPN option for production traffic because there is no SLA on the internet. You might be hopping from 2 or 5 or 6 different locations and coming back to AWS, and your latency might not be the same, right? So it's okay for non-prod traffic or from testing traffic, but it's not okay for production traffic, right? So how do we add more resiliency into the picture? So we bring in multiple locations. So for critical workloads, our recommendation approach is that make sure you connect to 2 different direct connect locations, right? In Australia, you have Melbourne, right? You have Perth, you have Sydney. In Sydney, we have 3 locations, right? So you need to make sure that you are connecting to at least 2 different locations, to the region, right? One can be in Melbourne, one can be in Sydney, right? If one goes down, you still have the pipe from the other side, and it may be going to the same data center, it may be going to a different data center, right? The other thing to keep in mind is that make sure that it is being terminated on different devices on your side. You don't want to terminate both locations on the same device because, again, we are stuck in that same issue where resiliency is a problem now, right? But we do have customers who might come and say, look, if one of these links goes down, it's still not acceptable, right? So for maximum resiliency, we actually recommend 2 devices on your side, 2 devices on our side, and 2 locations, which gives you the highest SLA possible from Direct Connect service as well, right? So imagine that if one device on your side is under maintenance or our side is down on that maintenance, for example, you still have enough capacity on the second link within the same location, right? So this pattern will give you maximum resiliency possible with the Direct Connect. And we do have resiliency toolkit within the Direct Connect console, which you can actually go and click on it and just walk through the process, right? Now, how do we do resilient connectivity with branches? So generally, when branches are coming in, they might be using a VPN. I mean, VPN is without an SLA because you might be using internet traffic for the likes of Telstra and Optus. Like you might be using a WAN network or 4G or 5G to come into the AWS network, right? There is an option for accelerated VPN. Without going into the details, accelerated VPN actually allows you to actually put that traffic on our backbone as close to you as possible, and then we take that traffic on our backbone to our region, right? So have a look at that to add more resiliency factor into your VPNs. And if you're using SD-WAN, a lot of our customers actually are using SD-WAN in AWS, and then they do GRE tunnel back to transit gateway to BGP trade the routes. Make sure you follow the resiliency guideline of the single VPC. For example, you need to have multiple headends or multiple SD-WAN appliances within the connectivity VPC or SD-WAN VPC, whatever you want to call it. Just want to make sure that you follow the best guidelines there as well. Make sure you understand that the EC2 instances which are running SD-WAN software, they are AZ bound. So if there's an impairment in single AZ, you want to fall back to the second zone as well. So make sure there is multiple head ends, and that's how you are advertising the routes back to your branches as well. You might use AS path prepend from BGP to make sure one is preferred over the other. But if one goes out, the secondary path takes over right away, and you fail over immediately. Cool. So let's go multi-region. So let's imagine we have a network running using transit gateways, and you want to connect your US workloads to the Australian workloads, right? You can use, just like VPC pairing, you can pair transit gateways outside your region, within the region now you can as well, and outside the region as well. What that means is you are using our backbone. You don't need to provision the capacity from, like, say, international bandwidth providers or telcos, right? We take that traffic for you. We provide you that path to other regions. It is a highly resilient path. It uses our backbone, which is redundant 100 gigabit Ethernet backbone we have around the globe. If one circuit goes down, transparently we route traffic from other ways back to the US, right? So you don't need to worry about that resiliency because it's part of the offering, right? And then it can scale to thousands of VPCs. You can scale it to multiple regions, and you can create a full mesh kind of network as well, right? And the beauty is that it's fully automated. You can just make an API call on both sides, and you can just set up this pairing and put routes in, and then your regions are talking to each other. So generally, customers, what we'll do is the customer's networking team will go ahead and create this full mesh network around the globe between the regions, and then workloads can talk to each other. And you might have these inspection VPCs within each region where you inspect the traffic before it goes out to the region, depending on how your business profile is and how risk-averse you are. There's another pattern, and when you bring in your hybrid network into this, imagine your Direct Connect gateway allows you to connect to multiple transit gateways. So imagine this pattern now, where your data center A and data center B are using two different locations, and then using Direct Connect gateway, they're attached to transit gateways as well. So now imagine that full mesh network has been extended to your own premises as well, using the resilience connectivity, using Direct Connect and the transit gateway pairing. And every workload, for example, data centers can talk to data center, a data center can talk to the workloads. And if you want to make sure data centers can talk to data centers as well, you can add SiteLink, for example. So SiteLink is a feature on Direct Connect. You can turn on my API call, and you can make sure that your data center A and data center B can talk to each other without going to the region. Why is that important? Because imagine a customer in Melbourne, right? They have two Direct Connect locations in Melbourne, but they're using Sydney region. So if you have both of these data centers in Melbourne, when you want to reach out to your workloads, you're actually getting within metro. So you will be connecting to each other within Melbourne. The latency is, the data doesn't have to come back to Sydney, and the data centers can talk to each other, right? We've seen use cases with SiteLink where customers are building their DR network. For example, they want to build data center to data center communication, and they use SiteLink for DR. I've seen use cases where customers actually use it for backup network, for example, that I need a job which need to transfer like gigabit of data from data center A to data center B. I will turn on SiteLink from, let's say, morning to the end of the night, and then transfer the data, and done. So you dynamically provision that connectivity between your data centers. You only pay as you go, and then you turn it off, right? So have a look at SiteLink, which provides you that resiliency on top of the Direct Connect resiliency we built earlier. Then lastly, I want to talk about, like, if I take us one step back, the transit gateway design, but it starts getting complex. When you're building this full mesh network, it gets complex as well because you're maintaining those peering relationships, et cetera. So we've heard a lot from customers around making it easy to do segmentation within transit gateway, or how do we do automation around the global network you now build, right? So back at reInvent, we launched something called AWS Cloud WAN, which allows you to build global networks on AWS using centralized policy. You literally write a JSON document that I want this network to be in these regions. These attachments can talk to these attachments, etc. So everything is a JSON-driven policy, and then that simplifies your WAN networking. How does it look like on a high level? Cloud WAN looks like this. You can attach your VPCs, you can attach your SD-WAN, you can attach your branches, Direct Connect, Transit Gateway, everything into it. You might be thinking, look, it looks like Transit Gateway, right? The Transit Gateway is a regional service. Cloud WAN is global, right? It's a global service. You define it. The control plane is global. And we do have like Transit Gateway-like constructs within each region. as well, which we'll take a look at. But the beauty of the service is it allows you to create these segments, right? So you might, in the policies file, say that I need 10 segments, business A, business B, business C, or prod, non-prod, et cetera, or PCI, non-PCI, right? Then based on your criteria, your tagging policies, VPC IDs, you can actually automate the attachments, that all these attachments can fall into segment A versus B versus C, right? And these segments, think of it as a global VRF. If you come from a networking background, think of segments as global VRF on our backbone. Each segment can talk to each other globally, but they can't jump the segment until you leak the routes between or inspect the route with the firewall, right? So something to keep in mind is that there is two ways to do global networking. One is using transit gateway, one is using Cloud WAN. Cloud WAN is a managed service, very opinionated service, that how you do cloud, but it's really easy. You just write a policy document, and that's all. All you need to do, you don't need to create the pipeline for transit gateways, et cetera. And a lot of customers actually ask that, what is the difference between them? So transit gateway is absolutely beautiful. It's a beautiful service. I love it. But the thing is, it's managed by customer, right? So you need to build that pipeline. You need to build that route table, and you need to maintain that operational side of things. Cloud WAN, we manage it for you, right? You write the policy, we build everything for you. It's similar to transit gateway. It allows SD-WAN connectivity, segmentation that are across the regions, and you can still do direct connect via TGW pairing, et cetera, as well, right? So think of it that, do you want a full DIY configuration, or do you want AWS to manage my network, right? I've had customers who actually said that we are not network savvy, we are developer focused. So all we want is a global network which can talk to each other. For them, with Cloud WAN is really suitable. You just click and you go from there, right? Cool. So I've added some resources here. This session is recorded. You can always come back and have a look at it, I think, on the portal. It will be on the YouTube at some stage. Some of these links will talk more about resiliency, how do you build resilience, direct connect, et cetera. How do you deploy firewalls and stuff like that as well. I think next steps from here is that follow the best practices to build resilient cloud networks. One thing as network engineers we need to do better is that we need to understand we are building these networks for applications. So keep in mind that metrics we talked about initially, that when you're building resiliency, keep in mind the application space and how resilient the network needs to be, right? So wherever possible, use static stable systems. Make sure that you have those resources pre-provisioned, or they're statically stable in cellular fashion. If one cell goes down, you still have the other cells as well. Use highly resilient services like transit gateways. Use AWS backbone wherever possible. You don't need to build. You don't need to buy a resilient backbone from telcos. It's readily available for you. We manage the capacity for you. We flex it for you. We reroute it for you, right? So you don't need to, go back and buy those things for you. And then use the resiliency toolkit like Amazon Route 53, ARC. You can use Direct Connect Resiliency Toolkit, which can allow you to test the resiliency of your hybrid cloud networks, et cetera, as well. Within the resiliency toolkit and your Direct Connect console, now there is an option to turn down the BGP. So you can actually shut down the BGP peer and test out, like, how would my routing policy will work if this link goes down. So do test and test often, and make sure that you're aware that how the backup connections and backup things will work. And lastly, your time is now. I think make sure that, improve your skills. We're always releasing new services. We're always adding more features. I think one way to do is, training and certification do an awesome job. So if you join those trainings on demand, we cover a lot of these topics in those trainings as well. If you need more connection with the networking people, we have a booth, global infrastructure booth here as well. You can bring your networking questions down there, and specialist teams can actually help you there as well. Hope you enjoyed the session. Hopefully it gave you some perspective how to build resiliency within your cloud networks. And thank you for coming in, and here's my contact. If you need to contact me, reach out to me on Twitter, reach out to me on LinkedIn. And please do fill the survey, what we can do better and what we can do next. Thank you.